So for those of you who don't know me, my name's Jeff Eggleston. I work for IBM. I'm a Z technical specialist. And one of my roles in GSE is helping with hosting the sessions. This is not my regular job in GSE. I'm just filling in for somebody as the committee lead. So as one of the things about this session, if you've got any questions, could you put that in the chat, and then hopefully we'll be able to get the folks to answer it. And that's as we go along. So what I'm going to do is not waste any more time, but hand it over. I guess it's to Carla first, and I'll let you do your introductions to this section, Carla. Oh, sorry, Diego, I do apologize. I'll hand it over to Diego, and if you can do your introductions in the interest of time, that'd be really good. So thank you.
Okay. Hi, everybody. I'm Diego Taddeo. I'm working for Sogei since 2003. I was IBM Z OS system programmer for 13 years. And now I'm working as IT architect for my company. And I'm focused on cloud technology, especially on IBM Z, Linux on Z. And I've been IBM champion from 2020 to 2024.
Hi all, my name is Carla Raffi. I'm in Sogei till 1991, and I deal with monitoring and observability in the last period. And I'm also a cloud architect and interested in the developing of cloud in Sogei and the way with the Sogei is approaching to the cloud. And in this presentation, I will deal with the information about observability of the solution.
Hi everyone, I am Andrea Cherici. I am a cloud architect, and for the last 2 years I focus my activity on automation. Automation to offer our customer the same experience we have with the cloud provider.
In this session, we will drive you to our company cloud adoption. We will focus on the cloud native services on Z. We will talk about the benefit that Z platform can bring in our company, the infrastructure and the automation. Before begin, please let us spend a couple of minutes about our company. Sogei is the in-house company of Italian Ministry of Economy and Finance. The main focus of our company is to support the public administration to the digital transformation process. We work closely with Italian government since the complexity of Italian fiscal laws is very high, and we work together in order to create IT services easy and efficient to use for our citizens. Our company is focused on new technologies, and we are aware to create the right internal skills to manage and develop these new technologies. Leverage on the new technologies, we can provide modern and innovative services and solutions to our clients. Just outside the pandemic, Sogei decided to review its services in a cloud way in order to be more flexible and deliverable. As you know, cloud can be on-prem and public, and like other big IT companies, we aim to embrace the hybrid cloud paradigm. So we began to start our transformation to promote our services delivery from legacy to cloud model. And since we have many different kinds of applications driven from Italian laws and rules, we need to put every single service to the infrastructure that can run this application better. So we decided to adopt a fit-for-purpose approach. The idea is that every new application requirement should be analyzed from a semi-automatic selection framework in order to decide what will be the better platform to run on. Basically, we have two kinds of users. Our clients, most of all, are the Italian citizens, and company internal users, because the infrastructure services are also deployed and managed by cloud model. So the idea is to manage this kind of users using two portals, a digital ecosystem portal with a catalog of services for our client and an internal cloud portal for internally company users. We selected this quote from Socrates about the innovation since it's very true, especially on the platform. The secret of change is to focus all of your energy not on fighting the old, but building on the new. Why we choose IBM Z as cloud platform? The first point is that in our company we already have IBM Z machines running ZOS, so basically we already got the hardware and the knowledge. The second point is that IBM Z has some unique capabilities we want to exploit. Just to introduce you some concept, I'd like to highlight some benefits coming from this architecture. The first one is the reliability by design, since every hardware component of this service is fully redundant. The memory, for example, is managed by RAM, so if you lost a RAM stick, you can continue to work without interrupt your services and applications. The CPUs are also redundant, and the cooling system too. So basically, it is a server designed for enterprise workloads. The security is one of the main unique characteristics of this platform, since Z has a symmetric cryptographic accelerator per core. If you select the Intel x86 machine only have one accelerator for socket. So basically one accelerator is shared between different sockets. IBM Z is one-to-one. Another feature in terms of security are the Crypto Express cards that basically are HSM cards inside the server, and this kind of cards permits best civil standard in terms of security. In fact, it's adhered to FIPS 140-2 level 4, and the commercial HSM you can find on the market adhere to FIPS 140-2 level 3. So basically the HSM that you find in IBM Z are the most secure in the market. And these two capabilities that IBM Z got permit you to run a Linux workload in a secure execution environment. Another feature is the cloud scalability on-prem, since on IBM Z you can activate some capacity on demand. Since hardware already have the dormant resources on board, and you can provide the flexibility of cloud on-prem, just activating and deactivating the resources you need. Another good pillar is the performance in terms of data management, since IBM Z include an AI inference accelerator, and you know that the I/O performance throughput is top level on that machine. So basically it makes this architecture to be one of the best in the market for the data analytics. Last but not least, very hot topic in this period is the energy efficiency. An IBM Z machine can run up to 200 CPUs and 40 terabytes of memory with a top power consumption around 20 kilowatt, about 65% lower than an equivalent computational power on x86 servers. So this architecture basically is not true, but very actual platform to run cloud on. So now you know about the IBM Z capabilities, but what we want to exploit. As we saw in the last slide, we understand that the key points are the security and the data acceleration. So the use cases are consequences of that. Crypto-intensive application, for example, application that need to encrypt and decrypt large amounts of data. This kind of application can benefit of per-core crypto accelerator CPACF, And we did an internal test in our lab, and we saw that the same workload with the same operating system, same Java virtual machine, and so on, in a single thread ran 5 times faster on IBM Z compared to x86. And in a multitasking environment, this ratio climbed to 10 to 15 times faster on IBM Z. Key Manager or HSM as a service is another interesting area we want to implement. Since IBM Z have internal HSM, this kind of HSM can easily manage cloud keys and also provide HSM as a service for our customers. IBM Z is the only on-prem architecture that permits to run workload in a confidential computing, meaning to have an application context fully encrypted. The memory is encrypted too, so only the owner of this workload can access to it. The infrastructure admin cannot retrieve any information from this environment, since even if they dump the memory, you can see only the encrypted data. So this technology is called secure execution, and it is possible only on KVM hypervisor on Z. Another context we want to exploit is the AI and machine learning workloads that can benefit from IBM Z AI accelerator, basically from the Telum processor, since it's part of IBM Z socket and it works in syncs with other cores. So it's more fast than x86 GPU, and it's perfect to run in-transaction analytics with very low latency. So basically, if an application needs to run in-transaction analytics within a large amount of transaction rate, this is the best platform to run on. OpenShift Container Platform is the key for the future, and the capabilities we discuss are perfect to run in a containerized environment like OCP. In addition, if your cloud application needs to engage the ZOS workloads, this is the right platform to run on, since you can have a direct connection memory to memory with the ZOS application and DB2s. So our IBM Z cloud environment is used to complement our cloud environment in order to run a specific workload that can benefit from his capabilities. Let's talk about infrastructure. To build our cloud platform on Z, we used Linux, and to provide hypervisor orchestration platform, we adopt IBM Cloud Infrastructure Center. IBM Cloud Infrastructure Center, called as ACAC, is based on OpenStack and exposes its API. So basically is completely compatible with the framework using this kind of API. ICAC can run both ZVM, that is IBM Linux hypervisor, and KVM, that is basically the open source hypervisor provided with Linux. In our shop, we use KVM since it's open and most know from the people coming from the operation on x86. So basically people coming from x86 already have experience of this kind of hypervisor and can easily manage it also on IBM Z platform. As OpenStack, the cluster of ICAC is made of two main types of nodes, master nodes and compute nodes. Both nodes run in the Z as LPAR. The master nodes are basically the controller nodes and are used to run infrastructure services for cluster functionality. The compute nodes are the nodes where the virtual machine runs on. Despite the OpenStack on x86, ICAC is more simple since you don't need to bother you with undercloud and overcloud concept. The installation, in fact, is very simple. You only need to create a Red Hat Linux helper for both management and compute node, install the software using the script on management node, and when the software is installed, from the graphical user interface, you have just to connect your compute node, so ICIC can automatically inject the software and onboard this compute node inside the cluster. That's it. The removal of compute node works in the same way. It's very easy. The update of the infrastructure can be run without stopping your services, since the update is concurrent. And this kind of feature is very important since we are running on IBM Z, and you know IBM Z is an enterprise platform. So basically, you should never stop your services, your application, to do some maintenance on your infrastructure. OpenStack is a cloud-native infrastructure and is the basis of many cloud hyperscalers. So the way of engaging and management of this platform is very similar of what you do in a public cloud environment. A very interesting and unique feature of the ICIC is to support compute node in a secure execution mode. So with this kind of node, you can run your services in a fully encrypted context where the ICIC administrator or helper administrator cannot read any data from this context. Even the memory is encrypted. So if you dump the memory basically cannot read because it's encrypted. This is the confidential computing feature of ICIC. And this platform is the only on-prem platform that permits confidential computing. The evolution of ICIC started from 2021, and this product grows so much from that date. We have a direct contact with the development teams of the product, and we provide them feedback and improvement in order to evolve the product to the feature we and our clients needs. The guys from the lab are very open-minded and very fast to provide new feature on the product. In this slide, I'd like to show you our architecture. The design is based on the concept of high availability and scalability in order to provide flexibility and performance. We have 3 different Z16s in 3 different and isolated rooms of our data center. In each Z16, we have a manager node in high availability and some compute node, at least one normal compute node and one secure execution compute node in each room. The manager nodes expose the graphical user interface and the API to interact with the platform. Regarding the storage, we have a software-defined storage configuration made using IBM Spectrum Storage Scale. Storage Scale X Spectrum Scale permits you to virtualize your physical storage in virtual pools, giving you the flexibility and the abstraction from the physical layer. So, for example, you can change your physical disk in your pool without affect the applications, since the data movement between old disks and the new ones is made by the product transparently. With storage scale, you can also manage the replica, synchronous or asynchronous, of your physical disk, and encryption, so you can define different kind of pools with different features in terms of replica, encryption, and performance to expose to your ICIC infrastructure. The main idea is perform management operation without affect the services. We talked about the feature and the infrastructure, so now we know that IBM Z is a cloud-ready platform. So let's talk about the cloud approach. The idea is to create and provide services using the same logic for every target cloud platform. So we deploy our services as code images as code, infrastructure as code, services as code. We can talk of everything as code. To do so, we use an automation layer that exploits common cloud deployment frameworks and tools. Packer for the images, Terraform for the infrastructure, Ansible for the configurations, and Argo CD for the continuous delivery on OpenShift. All these tools can be used for every target cloud platform, so the provisioning of cloud services is based on the same flow using the same automation tools. IBM Z is just one of cloud platform can be engaged in the same common way. Now I left the floor to Andrea that we talk you more deeply about the automation framework. Thank you.
The first topic I want to talk about is why we need pipeline to implement an automation flow. As you can see in the picture, the automation tool icons are placed inside a gray box with the symbol of a pipeline on the top. All these automation tools are basically command line tool designed to be used by a single user through a CLI. So we need a solution like Azure DevOps Pipelines to group together the automation tool execution and to have all we need to manage the automation in a production environment. This solution provides us the API and the web UI to start and monitor the automation execution. Here we can view the logs and check for an error. It can trigger the automation when a Git repository is updated. Securely manage the secrets and the password we need to work with our infrastructure. Profile user and application who want to engage the automation, granting or denying access to pipeline execution and pipeline resources. Automation is mainly implemented by two kind of pipelines. The build pipelines, the one on the left side, performs the build of VM image using HashiCorp Packer tool. The provisioning pipeline in the right side is responsible of the resource creation and the reconfiguration. This is the core part of the automation, and we'll see it in depth in the next slide. This slide shows how the provisioning pipeline can be engaged. Basically, we can have two approaches, the provisioning approach and the GitOps approach. In the provisioning approach, you can directly invoke the pipeline API, passing the resource configuration you want to create or update. In the GitOps approach, you can commit a resource configuration file in a Git repository to trigger the pipeline execution. These two approaches are very common and are often used together in automation scenarios. For this reason, we have created a YAML manifest file which fully describes the resources are going to be created, and we use it in both approaches. In case of provisioning, the manifest file is the payload of the automation API. In the GitOps approach, is the file stored in the Git repo. In this way, we can work with the same pipeline in both scenarios. When the pipeline is called with the provisioning approach, it also updates the repository with the current configuration, so the repository always describe the actual state of your infrastructure. In this slide, we take a closer look to the manifest file. The manifest file we use is pretty similar to a Kubernetes one. It has the same structure, and the main section, kind, metadata, and specs define the same information set. People who work with Kubernetes or OpenShift can easily read this manifest. Let's analyze it together. The kind section defines the resource type is going to be created. The information contained in this section identify the software package implementing the automation and its version. The metadata section uniquely identifies the resource is going to be created. It could optionally include labels and annotations. The specs section defines the properties and the configuration of a resource. In this sample, we create a basic default VM only giving its name and the IP address. Here we show the main steps of a provisioning pipeline. The pipeline can be started with three different actions: create, apply, or destroy. Create and destroy are self-explaining, while apply is used to update an existing resource. In the first step, the pipeline downloads from an artifact repository the software packages containing the automation code. In the second step, the downloaded packages are unpacked, a Terraform project and an Ansible playbook are created. Then a Jinja template is applied to the manifest file to build the Terraform and Ansible input variable files. The created project can be optionally committed to a Git repository. Now the pipeline is ready to launch the Terraform code. It mainly interacts with the OpenStack API to create resources, but it can also interact with other products. For example, we use Terraform to create a record on a DNS server. Once resources are created, an Ansible playbook configures the VMs. Ansible is also used to configure the products for which Terraform provider is not available. For example, we use Ansible also to register the VM on a CMDB and for its onboarding on CyberArk, the company security platform. Now we are going to see a short video showing the provisioning pipeline which performs a VM creation. From the web UI, we can choose which pipeline to launch. In this case, we launch the provisioning pipeline. Then we set the input parameters in a YAML format and the action we want to perform. In this case, we want to create. Then the pipeline is started. Even if we are using an Azure Cloud Service, our pipeline steps are executed in a VM running in the ICIC platform. This VM is configured as a local Azure DevOps agent, and it is connected with the cloud through a unidirectional outgoing connection. This ensures a pretty simple and secure usage of the agent within our infrastructure. Azure DevOps records all automation logs and makes them available to monitor the pipeline execution. It keeps a list of all executed pipelines, which in case of error are also marked as failed. This is very useful for troubleshooting and post-mortem analysis.
Avanti.
The power is nothing without control slogan was first used in the Pirelli company's successful advertising campaign that showed an American athlete, Carl Lewis, as a sprinter on starting blocks wearing soon-to-be legendary red stilettos. The photo was taken by Hen Leibowitz in Texas in 1994 and became an icon of advertising creativity. In fact, we are now able to give automatically and in a very fast way power to everyone. The ones who succeed are the ones who find ways of achieving durable, consistent control over power. Control is based on knowledge. And how to achieve knowledge? Observing. Observability refers to the ability to monitor the behavior of a software system, understand its internal state, and diagnose problems. It provides a comprehensive understanding of the system behavior, health, and performance, and enables organization to detect, diagnose, and resolve issues quickly. Observability is a key aspect of our modern software development practices and is an essential tool for ensuring system stability, reliability, and availability. It provides a unified view of the system's behavior and enables organizations to detect and diagnose problems before they escalate into major issues. It gives an holistic view from the infrastructure to the applications. Here is our implementation. We collaborate with IBM Cloud Infrastructure teams and Instana teams in order to improve the Instana observability on the platform. The solution is based on 3 different agents. The first one is an OpenStack agent, which deals with the infrastructure and uses API to get metrics information from the ICAC infrastructure. Then the second agent is an OpenShift agent distributed by an operator on each worker nodes in the OpenShift infrastructure and able to monitor it and all the applications that run on it. The third one is an operating system agent, which is installed on each single machine, virtual machine provided by the ICIC infrastructure. The 3 agents together give an holistic view of the infrastructure and the application running on it.
Let's have a little tour in the Instana environment. I don't know if you know this dashboard. We have the OpenStack first of all. This is the hypervisor, so the master node, the 2 master node with the information and all the information about the instance count that are in the computer instance that are in the environment. This is one single computer instance with its network IP, with the typology of flavor, and with the information about the CPU, memory, resource. And then we have a Kubernetes OpenShift cluster, which is on the ICSE infrastructure. There are 9 nodes, a lot of namespace and pods. And in the 9 nodes, especially in the worker 5, we have the details of the different downstreams, and so applications that are running on these nodes. In peculiar, with working with the Nuovo Accertamento, that is our application. So we are able to come from the infrastructure towards the application, but also and have all the information about the component of the application itself. But we are able to go from the application towards the infrastructure in the other way around. So if we look at the Nuovo Accertamento, we have the same vision, of course, and we are able to look at the calls and the single traces that are doing in this period. For the moment, we can have a lot of information because Instana takes all the data from the microservices and the lot of sensors that are deployed, crafted, continuously monitor application performance, microservices, Kubernetes, database, API, and containers in real time with no sampling. So if we have a look at this single post, we can have lots of information about the status code, the time, the composition of the different parts of this span, and so the subcalls and so on. So we have the possibility to look into the application from the the beginning to the end, and have information of every single instances of the application. If there are problems, at the moment we have no problems, so we are not able to have a look at problems, but we can verify and go in deeper in the problem and find out which is the cause of the problem itself. Perhaps this first call is composed by 2 gets and 1 post, and there are information of all of them. We can go on to the next slide. Okay.
We have the pleasure to work with a great heterogeneous team. You can see here the different roles and skills involved in this project. Every specific skill is important since it's a wide scope project, starting from the hardware to the software development. So what we like to remind you? Z is a great asset with unique capabilities to exploit. Z runs standard Linux, so it's open to cloud and good for every use case. IBM Cloud Infrastructure Center is a cloud-native infrastructure and in fast evolution, so it's perfect to create your own on-prem cloud platform. We can we do with other cloud platforms, using the same API we found in OpenStack, and we can use the same tools we also use in other cloud platforms. DevOps and GitOps pipeline used in OpenShift are the same on both x86 and Z, so you can reuse all the DevOps pipeline on Z platform. Last but not least, IBM Z is perfect to provide enterprise-grade cloud services.
And now it's time for asking. Please, if you have any question for us, don't hesitate to send us in the chat, or if you want, you can contact us via email. Our address are here, and we will be glad to answer to your questions.
Yeah, it's Jeff here. I have a few questions, if you don't mind. I have to say I found the presentation very good. I like the introduction, but I like the demo. The key question I have, and if I missed it, I apologize, but are you able to give a sort of a typical timeline on how long this takes to implement?
But in terms to how time we need to design this kind of architecture, or
how long it takes to put it in?
Yeah, how long would it take? So you do all the architectural work and you put it in. Typically, in the projects you've worked on, are you able to give a sort of timeline? I mean, I'm not asking days or hours. Is it days, weeks, months, years?
Yeah, the main challenge was about the automation framework, because Andrea thinking about the automation to be a general purpose automation. Basically, we don't lock ourselves to a specific technology, but we want to use a wide different cloud technology, and we engage the standard tool like Terraform and Ansible to do so. And in order to have automation framework so flexible and so general purpose, it takes about, Andrea, one year, more or less, to be designed and deployed, because we need to have some multiple modification and improvement to get what we want.
In the same time, we have also an approach with the CSE team, because the develop of the new version was made together. So the long time is due to the fact that the infrastructure changed in the meanwhile, and changed due to the improvement that we ask and they give us.
Yeah, basically, I see. When we begin begin this project, the product IBM Cloud Infrastructure Center was so young. So many features were not available to the product. So we need to interact with direct contact with the IBM labs in order to bring this new feature inside the product and basically permit us to address our needs in terms of usability, in terms of scalability, in terms, for example, about security and virtual network and so on. So
and also monitoring at least.
Yeah, and also monitoring. Yeah.
Diego, Carla, thank you. I really appreciate that answer. That's very helpful. Again, we've got 12 people. We've had it up to 16 on as participants. The 12 people that are remaining. Any questions, please? We'll give it a little pause to ask. If you want to talk, then just put it on the chat and I will unmute you. Okay, well, I'm going to say that's a no. What I would like to do is, Diego, Carla, if you could say any finishing words that you'd like to finish before we bring this to a close.
Yes, the first things I want to say you is to give us feedback. Please help us to have a better presentation next time. So submit your feedback. I don't remember. Please remember that our code is AH, and there is also a graphic one if you want, and please give us feedback in order to get a better presentation next time. And the last is to say thank you to everyone who have attended this presentation, and thanks to our colleague that made the most of the work.
Right, Carla, I would like to emphasize your point that the guide share really work off the feedback, because that helps us decide on future presentations. So your feedback is very important. Another easy way to do it, by the way, is if you go on to your build your own agenda, if you click on the feedback, it'll take you straight there. So if you can't get any of these details, that's another way you would do it. So I'm actually going to bring this to a conclusion and basically say everybody involved, it's been a great presentation and thank you very much and have a good day in Rome.
Thank you very much to you.
Thank you for the possibility to participate and show what we are doing in our Z platform. Thank you everybody for
All right.
Bye.
Ciao.
Bye bye.
Bye. Ciao.